All right, this is chapter 10, video number 2. Last video we learned about how to write hypotheses. In this video we're going to talk about how do we decide which hypothesis to go with. What conclusions can we make? So I have two different examples, one in video 2, one in video 3. Hopefully that those will help us figure these out. All right, so according to QSR magazine, Chick-fil-A has the best accuracy of drive-through orders with 96.4% accuracy of all of its drive-through orders. That's not shocking. Chick-fil-A is amazing. All right, the manager of a competing fast food restaurant wants to advertise that their drive-through is more accurate. In a random sample of 350 drive-through orders at this restaurant, there were 345 correct orders. Is this enough evidence to prove that their drive-through has a higher accuracy? All right, so overall, Chick-fil-A is king of accuracy in terms of orders with 96.4%. However, another manager wants to state that they have better accuracy. So he did a sample, he or she did a sample, and we have 345 correct orders out of 350. And is this enough to prove that they have a higher accuracy? All right, so what parameter are we looking for here? Well, this one is talking about a proportion of correct orders. All right, that is what we are going with, proportion of correct orders. All right, and the statistic that we have been given in this, what was our sample? Well, 345 out of 350. Well, 345 out of 350, if I calculate that real quick, 345 out of 350, and simplify that, that is right around 98.6%. Not bad. Now, technically, in this sample, just looking at these, 98.6% is better than 96.4%. However, this is only a sample of 350, and this is a sample of pretty much all of Chick-fil-A's, a much, much bigger sample. Is this enough to state definitively that this has a higher accuracy rate than Chick-fil-A? All right, so let's go ahead and write our hypotheses. So first off, our null hypothesis is just going to be, hey, the proportion is the same as Chick-fil-A. There's not enough to say that it is greater or less than, just, hey, the proportion is going to be the same as Chick-fil-A. However, our alternate hypothesis is going to be that our proportion of correct orders is greater than Chick-fil-A, is greater than 0.964. All right, now, significance level. We have been using the exact same significance level so far in this class, and that is 5%. And I'm going to go ahead and write out the fancy way of saying this. We're going to say alpha equals 5%. And 5% is going to be the cutoff as to whether something is unusual or not. Usually if something has a probability of less than 5%, we say that that event is unusual. All right, so let's go. Down below, here is what I have. What are we expecting in this problem? Well, we are going to center this about our null hypothesis. We are expecting 96.4% order accuracy. However, we do have one sample that is going to be at 98.6%. 98.6%. 98.6. All right, and I want to know, what is the probability of this occurring? All right, well, guys, great news. We've already done a lot of this. We have already done most of the work on this before. We are talking about a proportion, and we are talking about an area under a curve. This is just a cumulative frequency, cumulative distribution. So let's go ahead and talk about our standard deviation here. Well, our standard deviation is going to be our square root, of PQ over N. All right, standard deviation is square root of PQ over N. All right, so we are expecting 96.4%, so 0.964. All right, if 94% or 96.4% of orders are accurate, that means that right about 3.6% of orders are not. It can't be perfect. All right, N. N is how many did we sample here? Well, in this sample, this restaurant manager sampled 350 people. All right, so 350. Ooh, that is a bad 3. 350. All right, now here we go. I'm going to go ahead and look at this on Desmos. All right, square root of 0.964 times 0.036 all over 350. Our standard deviation is 0.00996. 0.009 0.996. All right, so here we go. Let's go ahead and draw out our normal distribution. Here's what we've got. We have centered our distribution around 96.4%. Cool. We've centered this around 96.4%. Our standard deviation, we just calculated that. We just calculated that right there. And I'm going to go ahead and leave it right there. So here's what we're centered at. And here is our standard deviation. And now I want to know, what is the probability that we would get a sample like this? What is the probability we would be at 98.6%? All right, well, here we go. We're looking at 98.6%? Well, actually, I'll do it the easy way. 345 out of 350. All the way up to infinity. All right, and take a look here. We have 1.5%. 1.5%. Not bad. Now, we decided that our alpha was going to be 5%. Anything below 5% was going to say, hey, yeah, that's significant. That's enough to say that that is unusual. So in this problem, we ended up with a p-value, a probability of this event occurring. Our p-value ended up being right around 0.0146. 0.0146. So here's the conclusion that we are making. This is significant. This just didn't randomly happen. This happens because this person, this restaurant, has a higher accuracy rate than Chick-fil-A. So I'm going to go ahead and accept the alternate hypothesis, and we are going to reject the null. We do have enough evidence that, yeah, this has a higher proportion of accuracy than Chick-fil-A. So I'm going to go ahead and write out our final conclusion. All right, so here's what I've got for my conclusion. Because the p-value is lower than 5%, there is enough evidence to reject the null and accept the alternate that this restaurant has a higher accuracy rate than Chick-fil-A. All right, so that is our final conclusion. So real quick recap as to what the heck we just did. First off, we wrote out our hypotheses. Null is going to be that they're equal. Alternate is going to be, hey, we want to say that they have a greater accuracy rate. We did this just like we did in Chapter 7. We centered our distribution around what we were expecting. Our standard deviation, we calculated that based off of our null hypothesis. And then finally, we used Desmos to figure out, hey, here's our null, here's the standard deviation of that sampling distribution, and I want to know what is the probability that we had 345 out of 350 up to infinity, that p-value was less than 5, and because that p-value is lower than 5%, there is enough evidence to reject the null and accept the alternate that this restaurant has a higher accuracy rate than Chick-fil-A. All right, I'm going to do one more example in Chapter 3, but this is all we are doing for proportions.